Multidimensional scaling with Navure. The idea of multidimensional scaling, also called principal coordinate analysis, is to create, as in principal component analysis, a space with few dimensions in which to display the items without losing the most relevant information describing the relationships between them, but starting from a distance matrix. To illustrate this procedure, we will use the molecular markers test data set. Locate this file in the test data repository. This file contains 94 disease-causing cocoa fungal isolates collected from several countries in northern South America and Central America. Each row in the table corresponds to one of these isolates. To apply the multidimensional scaling procedure, click on the Multivariate tab and the MDS button. Select, drag and drop all the markers into the Traits panel. In the emerging dialog box, there are several options for generating a distance from the data. Multidimensional scaling requires a distance matrix as input. Molecular biologists use distances derived from similarity indices such as DICE, jacket or positive match, among others, which are appropriate for presence-absence attributes. We chose the Jacker option. If you declared a grouping factor, then all observations are summary by each class of the grouping factor or combinations of grouping factors. The way the summarization is done is upon control of the user. Observe that you can provide your own distance matrix. If you accept, you get an output. As with principal component analysis, multidimensional scaling produces a reduced dimensional space in which the distance between observations is preserved as much as possible. The amount of information retained by each dimension and their cumulative sum is shown in the second table. Almost 66% of all the information needed to reproduce the distances between observations comes from the space of the first two dimensions. The output also shows a chart. This shows the 94 isolates in the reduced space of 2 dimensions. Note that several isolates may have the same or a very similar molecular signature and are therefore represented by overlapping dots. As with principal component analysis, it is possible to assign different colors to the dots.